Hi everyone, welcome to Lecture 17 on law-like and accidental conditions. The objectives for this video are the following. So after watching, everyone should be able to, number one, describe how sufficiency can come in different grades. Number two, explain the difficulty in distinguishing accidental and law-like conditions by spatio-temporal scope. And number three, explain how laws might be said to be rules for revising our beliefs in a way that accidental generalizations are not. Now, this lecture will round off Chapter 5. There isn't much new material in this one. It's more of a philosophical exercise that reflects on some of the things we've been looking at over the past few lectures. So, to get started, let's look back at one of our staple definitions from the last week and a half. We've seen the following over and over again. A property F is a sufficient condition for a property G, just in case whenever F is present, G is present, which is the definition of sufficient condition. Now, have a look at the following examples of sufficient conditions. There are three examples down there. Number one says being a bachelor is a sufficient condition for being unmarried. Number two says a force of 1 Newton is a sufficient condition for accelerating an object of mass 1 kilogram at 1 meter per second squared. And number three says being in Tom's living room at 9 AM on February the 17th, 2021 is a sufficient condition for being English. Now, I want you to have a read of each example. They're all legitimate examples of sufficient conditions. I'm not trying to trick anyone with a non-example. And in a few seconds, you'll have a question to answer. So before that pops up, have a think about what is different, if anything, about any of the examples compared to the other ones. And when you're ready, move on to the question. Okay, so hopefully we've all had a think about that. Now let's look at the examples and ask why each one is an example at all of a sufficient condition. And doing that, we'll see some differences emerge. So when we look at number one, we see that the sufficiency of the condition there is due just to the meanings of the words involved. You might say instead that one cannot be married and a bachelor because part of what it means to be a bachelor is to be unmarried. Now we call this type of sufficiency analytic, and by that we mean it's true just by the meanings of the words involved. Now have a look at example 2. That example states a condition which is sufficient by virtue of a physical law. It's true by virtue of Newton's second law, which we saw in the example in the last video. Now, notice that the sufficiency in example 2 isn't analytic like it was in example 1, because we define 1 Newton to be the force required to accelerate a mass of 1 kilogram to 1 meter per second squared. And if we take that definition away, it's difficult to say how the sufficiency in example 2 is true just by meanings of the words involved, because in stripping away the definition of a Newton, one might say that Newton doesn't really have any meaning anymore. So example 2 is not analytic, and we call non-analytic examples like this one synthetic. Now, the analytic-synthetic distinction is not a straightforward one, and it has a very long and controversial history in philosophy. The examples I've used here are meant to be more or less uncontroversial, although you might disagree, of course. Okay, so we've got one example of analytic sufficiency and one example of synthetic sufficiency that's true by virtue of a physical law. That one was example 2. So let's look at the third example and ask, why is example 3 an example of sufficiency? Well, example 3 is true simply by happenstance or by accident. You'll just have to take my word for it that as I sit here preparing this lecture video at 9 AM on February 17th, 2021, there is only me in my living room and I am indeed English. Moreover, it simply happened that no one else came into the room while I was preparing this lecture, and this happy accident is what guarantees the sufficiency in example 3. So we call truths like this, true in virtue of happenstance, accidental truths. Notice that accidental truths are synthetic as well. Now, the point of all this is that sufficiency comes in different grades, and those grades allow us to distinguish accidental truths from law-like truths, like in example 2. And this distinction is important for inductive logic. The establishment of either sort of condition might be an inductive affair, but we might expect inductive logic to treat the two cases differently. Law-like sufficient conditions, after all, make up the body of science, and accidental conditions do not. A scientist, then, is interested in sufficient conditions like in example 2 here. They're not interested in analytic truths like example 1, because knowing an analytic sufficient condition gives us no new information about the world. All the information is already contained in the words involved. And they're also not interested, the scientist, in happy accidents like example 3. They would not want a property like being in Tom's living room at 9 a.m. on February 17th, 2021 in their list of possible conditioning properties, because even if Mill's methods singled this out as a possible sufficient condition, the scientist expects it to be an accidental one. So that brings us to two key questions. Number one, how do we distinguish law-like from accidental sufficient conditions? And number two, why is it that law-like conditions find a place in the body of science, but accidental ones do not? So for the rest of this lecture, we'll have a bit of a philosophical discussion about how we might answer these questions. So here is one suggestion that might look plausible in light of the three examples we've just seen. Perhaps the difference between accident and law is the difference between part and whole. Laws are truths about the whole universe throughout space and time, but accidental truths are those true of just a restricted part of the universe, like my living room. Now, you can ask, how successful is this answer? And we might say, well, it neatly explains why the body of science is concerned with law-like conditions. Science is concerned with patterns that recur throughout the universe rather than just particular spatiotemporal regions. Spatiotemporal meaning located in space and time. So science, after all, aims to explain and to predict. It aims to explain an event by showing it to be an instance of a general pattern, like explaining and predicting how objects move by appealing to general laws, like Newton's second law of motion, among others. And on the other hand, generalizations about my living room aren't much use to us in terms of predictive power because they don't cover much territory. And what's more, we can't pin down the sufficient conditions in examples like example 3 from earlier until we've already covered that territory. So we would have to completely survey my living room at the time in question to write down the sufficient conditions in example 3. So the predictions are kind of moot or trivial. And in contrast, we can't survey the whole universe, so predictions about it are non-trivial and they are useful to us. So suppose then that we try and define a law as a true generalization that does not refer to specific times, places, or individuals. Then all people enclosed in my living room at 9 a.m. on February 17th, 2021 are English is not a law, even if it's true. Now, this is problematic though, and one reply you might give is this. Why do we assume that this generalization is only about people enclosed in my living room? Because if being a person at 9 a.m. on February 17th, 2021 is a sufficient condition for being English, then not being English is a sufficient condition for not being in my living room at 9 a.m. on February 17th, 2021. And there are lots of things one might describe as not being English that aren't people. The moon, for example, can hardly be called English, and the moon is not a person. So, you might object, this generalization is not just about people, it's about a much larger class of objects, about anything at all, in fact. And if that's the case, then the class of objects referred to by the generalization is no longer spatiotemporally limited or even finite, and so it should be counted as a law by the definition we proposed. So we've run into a problem here. So you might say, okay, defining the difference between laws and accidents in terms of just their spatiotemporal scope is not good enough. But let's try and alter the definition we proposed. One major difference between laws and accidents seemed to be that laws are crucial to the structure of our whole view of the world in a way that accidental generalizations are not. The falsification of an accident might surprise us, but it wouldn't disturb us as much as the falsification of a physical law. So perhaps then, a little more precisely, we should regard laws not merely as beliefs about the world, but in addition as contingent rules for changing our beliefs under the pressure of new evidence. So what do we mean by that? Suppose, for example, that you have extremely strong grounds for believing that every person in my living room at 9 a.m. on February 17th, 2021 is English. Perhaps you've looked around the room, you've seen me to be the only person there, and you've checked my birth certificate to verify my English place of birth. Now suppose my American roommate was in fact hiding inside my couch, which they had hollowed out. You hadn't seen them when you surveyed the room. Then, if you view the generalization above as an accident, you would not be too freaked out about your generalization. Instead, you would just revise your generalization. And the point is that the fact that a belief is held with extreme tenacity doesn't guarantee that it's functioning as a law, as a physical law, even though laws are typically more stable and central pieces of our intellectual equipment than mere factual judgments. On the other hand, if you view the above generalization as a law, then you would have to conclude that my American roommate is not a person, or was not in my living room at the time specified. And in that case, you would have to seriously restructure your physical theory that accounted for these facts. The idea is that considering this as a law would disturb you much more if you found it not to be true than considering this generalization as an accident. So laws then do seem to have a special status as rules for revising our beliefs. But definition 2 isn't really that precise yet. What do we mean when we talk about laws being rules for changing our beliefs in light of new evidence, for example? Now, one way to make this idea more precise is to talk in terms of these things called counterfactuals. This means talking in terms of what might have been. So consider the following statements. Number 1, if this mass of 1 kilogram had been accelerated at 1 meter per second squared, then it would have experienced a force of 1 newton. And statement 2, all masses of 1 kilogram accelerating at 1 meter per second squared experience a force of 1 newton. Now, statement 1 is said to be a counterfactual condition because if the mass of 1 kilogram had not been accelerated at 1 meter per second squared, it would not have experienced a force of 1 newton. So its if clause, that first bit of the statement, is contrary to fact, hence why we use the term counterfactual. Now the law in statement 2 is said to support the counterfactual condition in statement 1. Now, if we review our accidental example 3 about me in my living room, we will find that laws support counterfactuals in a way that accidental generalizations do not, so perhaps this is a good way to try and separate them. So consider the following two statements. Number 3, if a person was in my living room at 9 a.m. on February 17th, 2021, then they would have been English. And number 4, all people in my living room at 9 a.m. on February 17th, 2021 are English. Now, statement 3 is a counterfactual condition and statement 4 is an accidental generalization. But we see that the accidental generalization in 4 does not support the corresponding counterfactual, number 3, in the same way that the law in statement 2 above supports the counterfactual in statement 1. If a certain person is not English and was in my living room at 9 a.m. on February 17th, 2021, I certainly would not say that they were not in fact a person or not really in my living room at that time. The accidental generalization wouldn't support its counterfactual counterpart. So perhaps then this is what separates laws from accidental conditions. Laws might be said to be rules for revising our beliefs in a way that accidental generalizations are not, and perhaps we can make this precise in terms of talking through counterfactuals. So maybe we're onto something. It should be clear that accidental and law-like conditions are different, but there are still questions left to answer in how we can make this all really precise. How, for example, do laws function as contingent rules of inference? And what are the rules for changing our beliefs about laws? Another question we haven't answered is what is needed for a law to support a counterfactual? And so these questions need answers if there's any hope of making all this kind of talk precise. But precise answers to these questions remain open in the philosophy of science. Okay, so with that, we've finished off chapter 5. In weeks 7 and 8, we'll look at the material in chapter 6, which has to do with probability calculus and making this idea of probability that we've seen time and time again more precise. So have a go at your self-reflections, and I'll see you all next time.